Welcome to Coding Sahai and Reshma. Before learning any computer programming language, we must know the basics of computer and programming. So in this video, we are going to learn the basic concepts of computer and programming. So the topics to be covered in this video are computer, hardware and software, programming languages, compiler and interpreter, and a comparison of compiler and interpreter. So the first topic is computer. Most of you know what a computer is. Its functions, its components, its advantages and disadvantages, application areas, all of you are familiar with that. Still, let's start with the definition of a computer. A computer is an electronic device that can be programmed to access data, process data and generate results. So, it is accepting data. That is, if you want to write your name or if you want to draw a picture, if you want to do some calculations, we are inputting data or we are giving data to the computer through keyboard or mouse. After that, it will be processed. It will be processed by the central processing unit or CPU and it gives the results. The result is our output and you can see the output in the monitor or you can take the printout of the output. Okay, so that is a computer. So all these process, inputting, processing and output, this cannot be done independently by the computer. So a computer works based on some instruction. Computer is an electronic device which can be or that can be programmed. So program means based on some instructions this computer is working. So the next topic is components of a computer. So in the picture you can see that input devices, CPU and output devices. So in the definition of computer I already mentioned that is computer is accepting the data. So that accepting the data, that process is our inputting. So for inputting the data, we need some input devices like keyboard, mouse. So you are inputting the data through input devices. After that, we have a central processing unit or CPU. The CPU is again divided into three parts: control unit, arithmetic and logic unit, and memory unit. So CPU is the brain of the computer and it is responsible for executing instructions and performing calculations in a computer. So now let's see the components of the computer. So the first part is control unit. Control unit is responsible for managing and coordinating the execution of instructions within the CPU and controlling the flow of data between different hardware components. That is from input devices to the CPU and CPU to the output devices. All these things are controlled by control unit. So the next component is arithmetic and logic unit or ALU. ALU is responsible for doing all arithmetical and logical operations. The next component is memory unit or the primary memory. So primary memory stores the data and instructions that are actively used by the CPU. That is, when ALU is working on some data and instructions, that data and instructions and the intermediate data, intermediate results, all these things are stored by the main memory or the primary memory, and this memory is not permanent where we cannot store the data permanently. To store the data permanently, we are using secondary storage devices. So next we have output devices. So the results generated by the CPU is sent to the output devices. The most commonly used output devices are monitor and CPU. So the results generated by the CPU will be sent to the monitor and you can see it and you can edit it. So the data we can see and edit in the monitor are known as soft copy, and the data whatever we are taking the printout. Printout can be taken using printer and that is known as hard copy. So these are the components of a computer. So the next topic is hardware and software. So already you know what is an input device and what is an output device. So this input and output devices and the CPU, these are all physical part of a computer. Input devices like keyboard, mouse, then the central processing unit. Inside central processing unit you have other devices like motherboard, processor and RAM, ROM, so many things are there. Then the output devices like monitor, printer, speaker, then the webcam, mic. All these things are physical devices of a computer and that is our hardware. That is, you can touch and feel it. So that is our hardware. Then we have another one, software. I told you already, the computer cannot work independently. Computer works based on some instructions. So these set of instructions are known as a program and that set of programs are our software. This software is required for the working of a computer. The hardware and software together make a computer system. Okay, so the examples of hardware are all input devices like keyboard, mouse, then the central processing unit and the output devices like printer, monitor. So these are all examples of hardware and the examples of software are our operating systems like Windows, Linux, Unix, then office softwares like MS Office, then Paint. So for the working of a computer, hardware and software are required. Both should be there for the working of a computer. So the next topic is programming languages. So what is a program? From the definition of computer itself, I mentioned that computer is an electronic device that can be programmed. So programmed, what does it mean? A computer cannot work independently. It works based on some set of instructions. That is, if we want to add two numbers, we have to give some set of instructions. How to add it? A set of instructions are known as program. And these set of programs are known as a software. A group of programs together make a software. So for writing a program or if you want to create a software, we must know programming languages. So for writing a program, we need languages, programming languages. Now we have to study more about programming languages. So the programming languages are, first it is divided into two, low-level languages and high-level languages. The low-level languages again divided into two, that is machine language and assembly language. And the high-level languages, the examples of high-level languages are like C++, Java, Python, then .NET. So many programming languages are there. And same way low-level languages we have are machine language and assembly language. If you want to be a programmer or if you want to learn any programming language, it is not Java or Python or C++ or any programming language, you must know these concepts. What is a program, what are programming languages, different types of programming languages and how it works. So this is very important. So now we are going to study what is a machine language, assembly language and high-level languages. Machine language. Computer can understand only this language. It uses zeros and ones to write the instructions. Zeros and ones are known as binary numbers and this language is also known as binary language. We are using decimal numbers. That is, from 0 to 9 we are using to write the numbers and the combination of numbers. But in machine language, it is using only 0 and 1. So, programmers used to write the programs in machine language. That is, to add two numbers or to display your name. For everything, they used to write machine language. It is very difficult to write machine language instruction, isn't it? But computer easily understands this language and directly executes it. It is so faster. So writing a code in machine language is very difficult. Moreover, it is machine dependent. What does it mean, machine dependent? That is, if you are writing a program in one computer, it does not work in another computer. That is machine dependent. So for each system, we should write separate code. So that is a disadvantage of machine code. Next, to find the errors in machine language is very difficult. Because all the instructions we are writing in zeros and ones, so to find the errors, it is very difficult. So the language of computer is machine language, or we can say binary language, but for us it is very difficult to write. So let's move on to the next programming language, that is assembly language. Assembly language. Assembly language uses English-like words, numbers, symbols, etc. to write the instructions. So the symbols used for writing assembly language program are known as mnemonics. For example, if you want to add two numbers, we can use the symbol ADD, and for multiplication MUL. So like that we have so many mnemonics in assembly language. So there is a question. Computer can understand only machine language, and we are writing assembly language program in English, and we are using the numbers also. Computer knows only zeros and ones. How a computer can understand this assembly language? Can you guess it? Yes, there should be a translator. If a person knows English and another person knows only Chinese, then there should be a translator, a mediator to translate English to Chinese and Chinese to English, right? So same way, here to convert assembly language program to machine language, there should be a translator program, and that translator program is known as assembler. So assembler is a program which converts the assembly language program into machine language. So there are some disadvantages of assembly language program. Like machine language, assembly language is also machine dependent. That is, if it is working in one computer, it does not work in another computer. Same way, it is not portable. So these are all some disadvantages of assembly language. So this machine language and assembly language we collectively call low-level languages. Years later, programmers introduced another set of language that is known as high-level languages. There are so many high-level languages, depends on the platform, depends on the need. So many high-level languages are introduced. The high-level language instructions are written in English, and it uses the symbols and the numbers. It is easy for a normal person to write the programs in high-level languages. Most of the high-level language programs are machine independent. That is, if you are writing a program in one computer, it works in other computer. So it is easy for us to copy a program from one computer to another computer, and it is portable also. So here also computer is facing a problem. That is, computer cannot understand high level language programs. So it should be translated to low level language. So here also we have translated programs. We have compiler and interpreter. So some programming languages are using compiler to translate or to convert high-level programs to machine language, or some other programs are using interpreter to convert high-level program to machine language. It depends on the program. You all are familiar with so many high-level programming languages like C++, Java, Python, etc. All these programming languages are using either compiler or interpreter, or some of the programming languages are using both compilers and interpreter. And we should know what is a compiler and an interpreter and how it works, and what is the difference between a compiler and interpreter. So the next very important topic is compiler. All programmers must know what is a compiler and interpreter. As I told you earlier, the programs written in high-level language should be translated to machine language. So for that we are using a special software called compiler. So compiler is a special program which is used to convert the source code or the programs written in high level language to its machine code. What is a source code? The programmers are writing the programs in high level language like C, C++, Java, Python, HTML or any programming language. The programs whatever we are writing, that is our source code. So it is written in English like language. We are using numbers, symbols, etc. for writing the high level language programs. We are writing in its own editor to write the programs. So that programs are known as source code. So the source code cannot be understandable by the computer. So it should be converted to its machine code. That machine code is also known as object code. Once you have written the source code in the editor, then we have to compile it. So compiler checks the entire program, then it will be converted to its object code. While checking the program, compiler may find out some syntax errors. So what is a syntax error? For writing all the programs, we have some set of rules and regulations. Let's take an instance. See, if you want to add two numbers, normally we write 10 plus 15 equal to. So you are using a plus symbol and equal to symbol for doing that addition, right? That is in maths. Same way for all programming language, there are some set of rules and regulations to write the program. So that is our syntax. How to write that? Some programming languages are using semicolon. Some programming languages are using indentation. Some programming languages are using curly braces. So there are some set of rules for writing a program. So that rules are known as our syntax. If there are any syntax errors, the compiler lists the set of errors and after compilation. So it will list a set of errors with line numbers. So if there are any syntax errors, then the compiler cannot convert the source code into object code. So it stops there and it will list the set of errors. All the errors should be corrected, then we have to recompile it. So that time if there are no syntax errors, then it will be converted to its equivalent object code or machine code. So that is the working of compiler. So compiler converts the high level language program into its machine code. So the next topic is interpreter. Interpreter also, like compiler, it converts the high level language program to its machine code. So the interpreter converts each line of code in the source code to its machine code line by line. That is one line at a time. It checks the line and if there are no errors, then it will be converted to its equivalent bytecode or machine code. If there are any errors, then it stops the conversion and it shows the error with line number. So you have to correct the syntax error, then only it will go to the next line. So line by line execution takes place in case of an interpreter. So the programming languages like Python, Ruby, JavaScript are using interpreter. For compiler, I told you already, it is C and C++ are using compilers. And like Java, like programming languages are using both compiler and interpreter. So let's see the differences between compiler and interpreter. So the first difference is, compiler takes the source code as input and it converts the source code into its object code or bytecode, and that bytecode will be executed by the computer. So it is like a two-step process. First it is converted to its object code and that object code will be executable by the computer. At the same time, interpreter takes the source code as input and it directly converts and executes the source code. So it is a one-step process. So in case of a compiler, the resulting executable file can be executed directly without compiler or source code. It can be executed directly. Compiler and source code are not required. But in case of interpreter, the code must be interpreted every time. So it requires interpreter every time for conversion. So we can say compilation is a one-time process and interpretation is a continuous process, because executable, after getting the executable file, then we don't need any source code or compiler for that. It can be directly executed. So it is a one-time process. But in case of interpreter, it should be interpreted every time. So it is a continuous process. As I said, compiler compiles the entire program in one go. So it is faster compared to interpreter and more efficient also. Then it is using less memory because it is already translated, but in case of interpreter, every time it is interpreting, so it requires more memory. So for finding the errors in a compiled program is difficult compared to interpreter, because compiler compiles the entire program, and if there are any syntax errors, it will be listed later only. So the list of errors, if it is a 10,000 line program, then if there are some hundreds of errors, then it will be listed later. So it is very difficult to debug the errors. But at the same time, for interpreter it is easy, because line by line checking is done by the interpreter. So if there are any errors, it will be identified at that moment itself, and you have to correct it, then only it will go to the next line. So in case of a compiler, the code must be compiled in each platform. That is, in each platform, the code must be compiled again and again. Because for every platform, the compiler is different. So in case of an interpreter, code can be more portable because it does not need to be compiled. Every time it is interpreting. So for each platform, interpreted languages work easily. So these are the differences between compiler and interpreter. Java-like programming languages are using both compiler and interpreter. So the advantages of compiler and the advantages of interpreter are used by the Java programming languages. So in this video, we covered what a computer is, its components, hardware and software, then programming languages, different types of programming languages, and compilers and interpreters. Hope you like the video. If you have any suggestions or if you have any doubts, please comment below. Thank you.